Is that a 3D printed?
3D printed floral.
That is good. That is good.
Whole food.
Ah, okay. Let's do a quick round so that we have some time. I think everybody's project is at different phases. Who wants to go first? Just 5-minute updates for everyone. What are the biggest roadblocks? What are you stuck? What are you trying to do? Kind of catching up. Yeah.
We can go first. We're trying to detect bilirubin for neonatal jaundice detection. And we've settled on using colorimetric testing. And so far we have our design is split into 3 phases. One phase is for separating plasma from whole blood. The second phase is catching albumin because the essentially the bad bilirubin in our blood is unconjugated and it binds tightly to albumin. So I was kind of thinking like an IF approach where if you can bind albumin, you can then try to directly test or directly measure the unconjugated bilirubin. And so we're good. That's phase 2, and then phase 3 is the actual detection with some diazo reagent that people use. We have most of the
And
stuff.
what is the dye for? What does it bind to? The dye.
To catch the albumin. It's just
It's just binding to albumin?
no, it's a broad spectrum protein binder. So right now in lab, all I have is Kumasi brilliant blue. But like you can think of like other dyes.
I think NH2 group binder.
Yeah. Like I've seen like BCG works the best, but we just have CBD in lab. We also have Whatman paper, which is good. It's a cellulose paper, which is going to be helpful for like the first 2 phases and separating the plasma and then functionalizing CBB on this to then catch the albumin. And then the biggest roadblock is actually the diazo reagent because you need the main components are sulfonylic acid and sodium nitrate. Yeah, it's just something that I don't think we have in lab.
But is that a dye that you guys can buy? What's it called? The azo dye? No.
Diazo reagents. They pretty much just so it comes in 2 steps. You're supposed to add like an accelerant that disrupts the H bonds, and it basically will convert your unconjugated bilirubin back into conjugated bilirubin. So they normally use this to do like total bilirubin test. But we're planning to find unconjugated and lock everything else out. So our total readout should be representative of our unconjugated. But the kits normally come in like big quantities.
I see.
We have to spend like $500, but per test it would be like $1 to $2. And I think like especially if we scale this up, then that cost could go even lower. But at least for prototyping, it's kind of hard for us to.
Yeah, and then just as a sample, with something like this, would you want to start with blood?
Yeah, so
the start sample.
For starting space, I'm gonna try to first use BSA to make sure that we can functionalize this paper well and bind albumin. And then one of my lab mates, he's using whole blood for some of his tests later this week. So I'm planning on sharing some of that blood.
Yeah, that's good. I think having some blood to begin with. Just on the plasma, I mean, we did this long time ago. We have a process for getting pure plasma out in
the centrifuge.
Yeah. So depending on if you guys need plasma, that's already something that's figured out. It's field ready. Yeah, let's talk about the azo dyes. Take a look, see if you can find other vendors or something, so it's not such a bulk. But it's useful to really try the entire process because once you do it once, you'll know where it breaks down. On the functionalization, there are printers out there, but I don't think you're not making thousands of these, so just do it by hand. Yeah, but there are very nice for RDT printing. Is quite common, and then it's just a printer that prints strips, and then you chop the strips. Okay, I think this is kind of a good, clean test. Remember, whoa, when did we choose the final presentation? Okay, Wednesday next week. All right, 1 week from now. Okay, all right, we should just do project discussions then. Maybe I'll just briefly mention what I have in the bag, here, but we could transition. Okay, but you guys have 90% of, do you have some of the reagents that
think-
come out or
We have
no?
everything except like the last step, so everything
see.
except for the diazo.
I
step.
see, and do you guys have a plan, a potential plan for it somehow or no?
We're still thinking, we're gonna discuss that.
Okay, yeah.
Today.
I
Check,
think like we found.
Kevin, can you do a search in our chemical repository?
Mhm.
Something, this is too specific. We work a lot in anemia. This,
Mhm.
But it's possible because we have all kinds of people kits. But why not just buy a smaller, they don't sell those.
We did.
I think the other thing would be is if we send some message to friends of ours in the Stanford office. Because I mean, they must run this, do they run this test? Is this something that could be in the Stanford department?
I think very well, yeah.
Every kid has to get a jaundice test, I thought, before you are discharged. It's a visual test.
It depends.
Yeah.
More,
So the person that I often reach out to, his name is Niaz. He's at Stanford, he's the head of Stanford, kind of the diagnostics unit, let's say. So just write a message to Niaz, mention that you're working in the lab. He works on TB. And say that we are looking for some place to get a jaundice kit. Okay, let's see how that goes. Just CC me.
okay, thanks.
Okay, who wants to go next?
I go
Anybody?
next.
Yes,
So our group is the Pacific Ocean monitoring, and I'd say our biggest roadblock is lack of materials.
okay. Yeah.
So,
And then who all is in the team?
and there's Roy, who's online,
Uh-huh.
and Divya, who couldn't
Got
make
it.
it today. but
Okay.
She's also on the team.
Yeah. And Roy is in India.
Yes,
Yeah.
they're both,
Okay.
Divya, both in.
Yeah, yeah.
And so I set up the meeting with Sofar.
Yeah,
Next
yeah,
week,
so
I'm gonna
let's-
go visit.
They said Thursday, something.
Thursday,
Yeah,
yeah.
that's too late. I just had a chat with Steve Monosmith yesterday,
Oh,
right
great.
after my talk. I have the code. So today, right after the class.
Oh, use the code. Oh, great.
Let's go. Find out from Danny.
I already did, I gave him, and I also have the code just in case you want to get out.
Oh,
That's
awesome.
it.
I can send it to you.
And
Yeah.
he has an entire Bristol mouth kit.
Okay.
And then I am willing to buy that kit eventually, so we can take a look at it.
Sure.
And again, the purpose of that was to get a sense for it. But it
Yeah,
is
yeah, I agree.
useful because at the end of the day, it's not frugal as yet.
Yeah,
That used to be an open source project in the past, so there's plenty out there on just how to put solar panels and things together. But I think the systems in part of it might be useful to think about how this particular sensor could be adapted to that platform. It's possible that that platform is too small.
Mhm.
And so understanding the limits of that platform would be useful. So do a deep dive on bristlemouth per se. Let's go, you figure out where this friend is. What's his name? by the way?
Cam,
Yes, and I've met him 3 times. And we have a joint grant together on this algae farm, right? And the units are all in that room, so at least you guys would be familiar with it. What's a key test? How would you know that that platform is sufficient? Do you have a good
like a-
metrics for the CO2 sensors,
I don't
like
have metric
weight?
yet. Leo,
Yeah.
said that he was willing to
Yeah.
meet for a call.
Can
like a
he meet
meet.
today, tomorrow?
I can.
Yeah, why don't you
message him.
ping him?
Yeah,
Let's do that, but
but would you be there as well?
yeah, I'm
Okay.
here now, I'm back.
Okay, good.
So I think the key thing to do would be is structure it in a manner that you have some specs, even if they are temporary specs for how much weight.
Yeah, wait.
And the issue is stability. Like if you have a buoy that's floating, and you want to put something on top of it, they will just flop around. And I'm assuming it's not a massively tall sensor, because when they're tall sensors, then they have to be put in these larger structures to stabilize them.
Mhm.
Versus if it's a tiny sensor, and then the thread to think about is how do you make something waterproof? So if you're really thinking about the general platform,
Yeah.
you can think about certain kind of sensors cannot have water or else they will not be functional. And is there a clean module that's associated? You should also list all the other sensors that have been adopted to the SOFAR sensor so far.
Okay.
Yeah.
But so as
You know
like.
what I did there? Only a few if you got it.
But for next week for the project meeting,
Yeah.
I mean, what are some deliverables we
I
can?
think the
show? Maybe like
deliverables
some
to really do
models?
would be is a deep understanding of the SOFAR platform. Having a good, clean idea on what Leo's team has been building. They don't have the final thing, but you have an intuition around that and thinking a little bit about a simplified version of that to begin with. And go back to the history of SOFAR so that you can identify the original project, because this then became a company per se, but overall, there are inklings in there that are useful to understand. So you really have a very good component kind of a context. And then possibly, if Cam is around, bring that platform and take the specs of that platform to begin with and see what would you build around to then support a sensor on top.
Okay.
Like, I think this would be the integration of the two. I think you will have access to one of the units, so at least you can take measurements, you can understand the power requirements. But how do you go about adapting a new sensor? And especially most sensors that I have seen that people have built on these autonomous floating buoys are underwater.
Yeah.
This would be the first one that is actually a surface measurement, which by itself has its challenges. So thinking a little bit about it, what does that entail? It really is a packaging problem that you're dealing with.
Yeah.
Like you have two pieces together,
Yeah.
but how do they come together? And now if you finalize that, yes, it's being built in the SOFAR context. I mean, one fun thing to also do is think about whether, I was just reading a paper today on comparing, I'll send you this paper, surface CO2 and underwater CO2 simultaneously. So you could understand the equilibrium kinetics that's associated, because with wind, it's not so clear. People still don't have a very good understanding for how much of the actual interface is completely in chemical equilibrium. How does that change as a function of temperature? Especially in parts of the ocean which are possibly emitting CO2. For example, the Arabian Sea is a source of CO2, not a sink. It's super scary to think, because there is 40 to 50 times more CO2 in the ocean. What if it starts to burp? If the ocean is going to be burped, we're going to be in big trouble. Like that's 40x the total CO2 in our atmosphere. So it's kind of interesting to think about whether there might be a chemical sensor for dissolved CO2 that's put in, and then this SOFAR platform will become really useful because it also has an umbilical cord that goes deep, and then these two measurements will correlate.
That makes sense.
Also, data would be an interesting thing to think a little bit about. So it becomes a little bit like the deliverable is that you have good, clean engineering knowledge in how these two things can come together. Even though physically, I think we should try bringing one of the buoys for people to see. The design is useful. Valuable to see that these buoys last that long. Okay, who wants to go next? Yeah.
Coral bleaching, we've got Peter, Debbie, myself, and Debbie that can't join out.
Yeah.
No. But so we're working on the alginate beads with our lens.
Yeah.
Well, okay, so that's our 3D printed coral. We've got multiple different species of different 3D printed coral.
Wow, this is so cool.
So rather than possibly harming the live coral, which professors, well, where are you? We're going to be using this in the tank and dropping all these different beads on, seeing if we can get transferred algae. We actually are having some trouble.
I think
but
focusing on making the beads is really a very critical part, because the first thing we have to tackle is build the type of a bead that the algae can come out of.
Yes.
Like trap is good, but if it's trapped forever, then it's not good. So thinking about watching and seeing to build a type of trap that decomposes, that you can spray paint something on, for example, spray paint still in the underwater. That eventually a first picture that you see is there is red everywhere with tiny little dots of those. but then you watch that decompose as a
Mm.
function of time. And
Mm.
like whatever the mechanism we're coming up with for the release side. I think that's the first really good goal. I think simultaneously, I would have liked if we can set up an imaging system. So even if you bring a tiny piece and just watching it and seeing what does the long-term time-lapse imaging look like. That's pretty straightforward for us to set up. We can set SALP, but we don't have to set SALP. We can also just set up our regular squid setup.
Okay, 'cause I've been trying with SALP and we talked about, I had some
So
difficulty.
let's play with that this week. But SALP will only have a limited magnification.
Exactly, that's what I noticed.
And so I think if we were gonna go, SALP is really good for really long-term setups when you really want to see the transfer. But the big missing question here is microscopic. So the idea would be is to set up the microscopic version of that.
And also then with the R lens coming.
And you can then also do with R lens, but this R lens doesn't require this. When you make the beads, have you guys made beads already? Do you guys know how to make the beads?
Debbie does.
Okay, but then you would just get beads. These are polydispersed beads, no single size, not monodispersed, right? Yeah, so do you guys know how to make a Frugal microfluidic device within 15 minutes? Yes, the answer is yes.
Yes.
Always say yes, there is a way.
It hits the surface at that height, then
Yeah.
everything is super problem.
Yeah, too much. You'll realize it'll lead into all kinds of splash dynamics and stuff. So 2007, there's a paper from Utada, and they show this was Dave White's lab that did a ton of work on droplet formation. Just two glass capillaries, one inside the other. I'll just draw that. It's super, super simple. And Hannah in the lab makes those. We also have a whole bunch of devices. But the idea is actually very clever. Going back and thinking about Frugal kind of a context. Microfluidics takes too much time, effort, devices break down, they jam all the time. What they did is they took a square glass capillary. These are manufactured in bulk, cost cents to make. So it's not a real square, but you get the point. And then they took a round glass capillary, which has the exact same, the OD of this is the ID of the square capillary. So the round glass capillary goes inside, and then with glass capillary on a flame, you pull it and you can break to make arbitrary nozzles. So depending on the speed at which you break them, even just by hand, you can get 10 micron, you can get 1 micron, you can get 50 micron, whatever you want here. So now here, this is kind of the nozzle. And here's the clever part, is that you flow your solution in one here, and then you flow your second solution in the gutter. So if I draw this cross section, you see that there is a remaining, this area right here. And then, and the clever way to do that is this thing comes out here, and you usually attach a plastic tube here, and then that tube goes down like that, while you attach another plastic tube that has a slit, and then you super glue the damn thing, and then you have this thing coming out. So you have one channel here, the other channel here, but when they meet, it only goes, liquid A only goes here, liquid B goes here, and you get these beautiful droplets. And tons of work has been done then after that on it. So this would be super easy to replicate. We have all the materials for it to replicate. If you can't do it, then I'll show you how. Okay. But just play around. All you need is glass capillaries, plastic tubes, and a glue gun.
Okay, cool.
And yeah. No, you make the nozzle, you fire up a Bunsen burner, you hold a glass slide, and then you just pull. It just breaks. Again, the most frugal way the original hatch clamping stuff was made. I mean, so you can get sub-micron resolution nozzles, and clearly you guys, what's the bead size you guys want to make?
Yeah. But I've done this kind of work before. We're trying
1
to
centimeter?
That's probably
No,
too big.
no. Not giant beads, no.
How small do you want?
No, I think they have to coat the surface. My intuition is you should do 100 microns or smaller. Because you want the algae is around 10 microns.
Yep.
So 100 micron would actually be good. So this would be, the nozzle would be around 50 microns.
Okay.
And again, the size of the bead is not such a function of just the nozzle. It's a function of your flow rates. So it's totally tunable.
Yeah.
And then there are a couple syringe pumps. There must be syringe pumps here also, right? In the lab, do you know?
No.
If there are no syringe pumps here, you can borrow from the lab for a little bit. And again, we have the entire setup, but I want you guys to make it. Like figure out, given the raw material, play with it to figure that part out. It would be valuable. And then the question is, do you put the beads on the inside? What is the rate of alginate dissolution? Or do you guys have any other materials that can dissolve so that, because one notion was that the R lens is on the surface as an attachment, but that would also mean that you would lose this precious symbiont. The other option is you make a bead out of a material that when it hits salt water, it actually dissolves.
What about with agar?
Yeah, I mean, this is kind of what you should massively search for, because this is completely orthogonal to the materials you choose for the beads. So this is independent. So one person should just focus on getting a ton of beads made. The other person should play with the material side. My intuition is that having the algae embedded and then dissolving is a much more powerful platform.
Then, okay.
Yeah.
So we already thought about that, and we've ordered the kappa carotene, which is known to interact with seawater at different temperatures. So we'll definitely play around.
Yeah, I think
Caribbean isn't in yet though, so we don't have that.
I see, but when does it come? Do you guys know?
It's ordered already.
I see.
I'll ask you.
Yeah, I mean, if it doesn't come, play with as many sets of things. But I think the ideal case situation in my mind would be is this becomes a platform that you then bring in, spray the stuff on. Also try playing around. What is the efficiency when you take a whole bunch of beads, it's in fluid, and you spray them on a coral, you would lose plenty of them. There's a classic boundary condition that they would just flow away. Which ones would stick? And thinking a little bit about what sticks to coral is an interesting bit to think about, because they have mucins. So that could also be a simple experiment that could be done.
Yeah.
We have plenty glass beads in the lab. Take a live coral and put tiny bit of glass beads or something to confirm, do they actually stick? Because when you are in solution, it's not impact force.
Yeah.
You don't want to impact it. You want to gently bring them on, but you do want enough yield. Like at least 90% or so of your things should stick. And that's something that you can also play with. So break these things down. There is the bead making, there is the escape and the breakdown, there is the capture efficiency, and then there is imaging. Like I think kind of a little bit of everything would be useful. But this is a trick that you guys should master. And then level 2 on all projects that utilize these droplet generators, then you're like, what about scale? I now need to make it in a kilogram scale. And so there's a lot of work that people have done for vaccines and other types of things, which are the high throughput versions of these. So imagine now capillaries like these mounted on a centrifuge. So they just naturally, there are centrifugal droplet generators. They make like billion-fold increase when you're thinking about these monodisperse emulsions at a massive scale. So that's another space that's very mature. It's there. People don't think about it in a cost effect because all of them are then for drug and pharmaceuticals. All of our many drugs are actually encapsulated. If you ever look at, this is one way, there was a team in, I'm trying to remember, in Kenya or someplace where they use foldscopes to detect fake drugs by looking for the encapsulation process. Because many fake operations have been able to repeat all parts of the process of pill making, but not the encapsulation. So that sort of led to, but in that space, and again, you can question, there is a second process that you can use, which we also have in the lab. It's the high-speed rotor. When we enter the lab, it's on the left side. So we have I don't even remember the RPM. It's an insane RPM rotor. It generates too much shear. So I'm a little bit worried about the live cells in it. And they also make polydisperse, but they would make somewhere between 1 to 10 micron beads. So that's another process that's used for bulk. And it's basically a rotor inside a rotor. So it spins counterclockwise, and then you take any solutions, it'll make mayonnaise out of it. Which some of you have made mayonnaise, right? It's the same process. Yeah, mayonnaise is an emulsion. Okay, so you have some of the things in place, but I would, just make the beads ASAP.
The other stuff that we were interested in was like, obviously the beads are not as frugal right now, and we're still interested in, I think that's part of the solution, but we also are grabbing some other materials that you can find in someone's garage. We've got cheesecloth, sponge, and other cloths that could possibly soak up the algae, and we're going to test them on that coral and see how they diffuse out and compare them to the beads as well.
I like that. I like that as a second strategy because there, the transfer yield is much higher because beads can float away. The cheesecloth can. So
secure it with it.
But I think maybe instead of a cheesecloth, what you then need is a breathable, extremely conformal object. How do you conform something to a surface that's so tortuous?
You can combine cheesecloth and spray paint. There's cheese spray.
Oh, and you can mold it.
Yeah.
What? There's cheese spray?
Yeah,
no, but it sprays cheese though.
Yeah, but here you're spraying the emulsion, but there's still a solid aspect.
Yeah, I like that. I think that also reminds me a little bit of the
spray web.
These are called non-woven fibers. Non-woven fibers are, again, now instead of the algae being in a bead, we can actually also embed them in fibers. This is how optical fibers are made. So then it would be a fiber-like object, and then it's literally wrapped around something. So then the yield is higher, but it would still be dissociating as a function of time. And fibers might be fun as an approach too. Okay, so you guys have plenty of ideas, but just start playing now because only 7 days are left. Okay, who wants to go next? Yes.
So we really wanted to explore.
And who all is in your team?
Oh, yes, so.
Got it. And who?
Rashad and Mohammed. Could you just put your hands up?
Oh, perfect. Okay.
So we really wanted to explore the drone aspect of mosquito surveillance. And really, it's mostly been used for looking for like still water to see like where the mosquitoes are growing, but not necessarily for action. Like,
It's used to map hydrology.
Yeah.
That's about it.
Basically. But we were kind of thinking about like how to make it frugal, because obviously deploying a bunch of drones is not going to be frugal. So we realized.
Although I have to say, I am quite surprised with the reduction in cost of drones, especially in the toy market. Now, the question is, some of them don't carry a payload. So that comes the tension, is what you're trying to measure and thinking about a drone. But many water bodies are really difficult to access. So drones do actually act as a pretty powerful. Okay.
But there's already drones that are used in a lot of countries to deliver blood and to deliver other medical supplies.
Not that many countries, but yeah, Zipline is there and
Six.
yeah. They have a lot of advertising. Whenever I go out there, the operations are still building.
Yeah.
Yeah.
One system already, they do like thousands of deliveries per year, which is significantly more than a lot of other places. So we were thinking, as that like starts to ramp up in other places, we're like trying to prototype a trap of sorts or some way to do surveillance that's modular and can be attached onto like an already flying object, and then map the distance that it's flying. Because if they're already doing these paths back and forth, then we can use that to catch geotag data.
Yeah, but what is the data that the drone is capturing?
So it's gonna be capturing the like mosquito itself and then using.
But in flight. So you have a very fast flying object.
Yeah, so through like imaging, and then you can use classification models because there's already vast amounts of data.
Yeah,
on
but
different mosquito species.
mosquitoes are small.
Yeah.
With an object flying very fast, you're not gonna be able to. So first of all, the mosquitoes are incredibly heterogeneous. And for the elevation that something like that is flying, you guys are not thinking of catching individual mosquito pictures or something, right?
No.
So that,
Wait, we were
yeah,
thinking about,
because that wouldn't work if you have an object that's moving so fast and flying. And actually, I mean, there's the complication there by itself because drones generate a massive amount of flow field. Even if there's only one method that I know that's worked in mapping mosquitoes at high altitude, which is a balloon with a sticky paper. This was the famous toys paper last year in Nature, where they show very high elevation, they open sticky paper and they were able to see and catch mosquitoes that taking the thermals. But yeah, I'm confused. How would it capture the flying drone capture the mosquito?
wait, yes.
Yeah.
Sticky tape.
Okay, this is the splat idea. Okay,
Yes.
okay,
So similar
okay.
to the splat,
Yeah.
like, since it's flying so fast, we have something attached to it that's also sticky of sorts,
Mhm.
or can trap mosquitoes in some way, and they can move in and also like be caught. And then we were looking at classification models that use like single pictures to
Yeah,
classify.
so then the pictures are taken from the splat paper that
Yeah.
it brought down.
Yeah.
Okay,
Exactly.
now I get it. Yeah, there's no way of imaging a mosquito on a flying drone. That doesn't work. Yes. Okay, splat. A couple of tricks around splat. So there's a little bit of a physics to be done. Let's do it all together. Back of the envelope a little bit. You have an object that's moving and you have a mosquito. What is the most common thing that would happen if a fast moving object arrives?
It's going splat. Like
I would be very happy if it would go
Too
splat.
small.
Sometimes
But
they
it's
go
gonna,
out.
exactly,
Yeah.
not sometimes,
Push
at
it.
all times. It's a function of
The
the
size.
inertia of the object. It's called the Stokes number for an object. So if the object had enough inertia, so I'll draw this again.
It's gonna have a bias on the size that actually hits.
What do you,
That's correct. So
what do you-
splat in the cars work for grasshoppers, for bees, for large things, because, you know, if you have an object here, have you ever tried to catch a fly with your hand?
Yeah.
What happens?
you got
It
the
flies
cat.
away. The reason you can't catch it is when you move your hand, the air right in front of you has to move. And that air sends a signal to the fly way before you are anywhere close, and it just flies out. So it knows, it doesn't need to see.
What if you fly, what if you have a fly swatter and you fly your
When
drone
you
with
do
fly
the
swatter?
swatter, so now you're thinking. So that means that a flat swat just does not work.
Yeah.
Because the object has no inertia. And effectively, if you move a plate, so imagine moving a plate in this direction at a velocity v, it's called the boundary layer. What will happen is all of this layer is stagnant and all of the other air will just pass by. And so any of your particles, they, the mosquitoes and other things will never arrive. And there's a critical velocity around it. So you have to do something else. And I think I would forget about the zipline drone is too specific a drone. Relax the condition that you have access to drones. Can you use the physics of the airflow in the drone to actually suck in mosquitoes like that? Then you're operating in reverse and you're actually utilizing. And some of the, for those to happen, you would still need something that is porous, that allows some things to pass through. Because if it's a porous object, you actually still have quite a lot of cross section that you can still get trapped. So it's a mesh. And meshes are actually used in the past in catching all kinds of things. But the cool thing to do and explore is for it to be efficient, because mosquitoes are in dilute quantities. For it to be efficient, you somehow have to use the physics of the drone and it's a little bit strange because drones push air down. That's how they can remain up, and they suck air from the top. If the opposite was the case, then it would be very nice, because then, but see if anybody has done complete airflows around drones to see and understand, is there a way to turn this into a suction mechanism? Maybe you can put an enclosure around it. You can change certain sets of scenarios that you change the shape or the enclosure that the drone sits in. So this would be one space. I think splat, and the higher the altitude you go, the lower the concentration of mosquitoes. So in an ideal case scenario, you actually want to be sampling around, 10 meters or less. That's really an ideal notion, just because, humans are there. So first of all, does anybody have a drone? You have a drone. Okay. So do you guys know how to map the airflow around a drone? How would you do that? Find a room with smoke. Fill it with a lot of smoke. Have a camera turned on and turn your drone on and see what that happens. If somebody's not, you should just do it yourself. This is kind of frugal imaging setup. I don't know what kind of smoke that it doesn't cause fire alarm.
That's what I was thinking. I was like, the fire alarm will go off.
Within 2 minutes, you guys will arrive. Mist. There you go. It's super simple to buy $20 these mist making devices. They have the ultrasound. Have you guys used those? Everybody's seen those, no? No?
Yeah.
But like the fog machine from the disco party, you guys don't borrow them sometimes? Yes? Yeah, they do not trigger
dry ice.
Dry ice is another one.
Just careful with displacing all the oxygen in the room.
Fair.
Yeah. But come up with something so you understand what does the flow field look like. Where should you design and put the trap? And then think a little bit about, just like Enrico is working on the platform you have the same challenge. Do you have a mount? Is there a way to mount something on this where the trap would be? And the trap could look very strange because you're exploiting the flow. So first of all, do you guys know the CDC light trap? Have you seen that?
Oh, yeah,
It's the most common trap. And there is one version of a CDT light trap that actually has a fan. So take a look at that. But most of those are, they are stationary. And so they lack the geotag data because you only do one place at a time. Now, if you have a drone, you have the additional challenge, which is it's moving around. So you mix up, where was this mosquito? And so remember, I had talked about the plankton recorder. What does the plankton recorder have? It has a tape. And so the distance in the tape is actually where the plankton is collected. So a combination of a plankton recorder, airflow from a drone, and would be the kind of space that I would think about. But I think you guys have to be super critical of the ideas now to a point. The analysis phase of the Fred Park is try a whole bunch of things, and then you can literally already test it. If there are mosquitoes around, try put a sticky tape and see if you can get even one mosquito. And you'll realize how hard it is.
Challenge is also like, in like a lot of times there's like, I know this personally, you always mistake flies and mosquitoes based on structural similarities, and that's gonna be something that we're
But
gonna.
I'm not too worried about that. Once you guys have the samples, then you can move to the step 2. I'm worried about not having any samples. Just because if you don't think hard about the airflow that the drone generates, you are already pumping them all away from you. That's it. So drone and mosquitoes don't mix that easily. You have to now, in a very clever way, think about what the airflow looks like. That can you flip this around and can you actually make a drone a suction device?
Sorry, yeah. Yeah, sorry, sir, for interrupting. Just
The whole
mention.
Discussion.
Yeah,
Yes.
just to mention, we were thinking also of taking inspiration, sorry, from the nature. Like there is some insects like the dragonfly, which eliminate mosquito, even flying mosquito. So we can take inspiration from this type of mechanism. It's called the biomimicry concept. So
Yeah, I mean, Dragonfly is a machine that I would say is a million-fold more complicated than a drone. Like, they are remarkable. And kind of, I don't think we are anywhere close to mimicking anything like a dragonfly as yet. They have a vision detection system. They identify mosquitoes and flies in flight. They do these calculations. I don't know if you guys have seen some of the movies from Genelia. HHMI had a massive dragonfly lab because they were interested in the nervous system of a dragonfly to understand how it's the fastest flying insect. How can it make those calculations in time to make these intercepts in air? And again, all of the control systems and anything like that, you would be much better off just using dragonflies. But at that time, then the number of mosquitoes far super exceed the number of dragonflies. But kind of, I think the thread that I would say is start with a platform, focus on collecting, choose one challenge. Once you've collected, there are plenty methods that people have developed already, which are image-based classifiers from splats and collected mosquitoes from the problem currently with these CDC light traps is that they're stationary. And so you don't get the much more distributed map. You get these and these point sources are tricky because at the end of the day, there is a ton of heterogeneity in the distribution. And then think a little bit about some of these cheaper drones, not the more fancy drones, but like, I think on Amazon, what's the cheapest drone that you can buy as a toy? No, I bought one for my daughter for $10.
Yeah, $20.
10, 20, yes.
Like, can it fly long enough distances that
It can fly. Yeah. No, I mean, I'm saying, but play with this parameter. See, why can it not fly? Think about that. It's like, oh, I just changed the batteries or I swap sets of batteries. And what I'm saying is the basics of what has been commercialized massively has been these toy drones. And you have a light payload. Like, it's just the physics of the drone itself that you're modifying. And so it's not totally crazy that you could build something for far cheaper. And again, it should just be across the board, play with it. But you should also at the least buy this $20, $30 drone too. And understand what is the physics of that look like. But you need to do it ASAP. Because and you know, some people might have done, of course, if you cannot design a drone without knowing what the airflow looks like. But I would like you guys to do it yourself. see if you can map the airflow of a drone. And again, it's 3-dimensional, so you have to play with it. It's unsteady because when the thing will turn on, it will be very different. And it's a little bit tricky. So the way you want to do this experiment, we're interested in the steady state flow. So you want to have the drone be hovering at a height and then introduce your mist or your source that you're going to visualize, because that's the only way you would know a little bit about what the unsteady flow field actually looks like. Okay, who's next? I know all of you have a project, so yes, go ahead.
Professor? Hello. Oh, sorry.
Yeah,
hello.
We're gonna.
Yeah, this is Shivam. This is Shivam.
Yeah, Shivam,
Hello.
give me 2 minutes. We're gonna cover plant pulse, and then we're gonna come to you. Yes.
Yeah, so we have that like demo that we brought, and so we're able to get it so that when we tug on the plant, we can see the laser moving as the demo. But I think the biggest issue we have right now.
The tug is massive compared to what
Yes. That's our biggest issue is the actual sensitivity.
Yeah.
Like
But have you guys made more prototypes yet?
We haven't gotten anything that's better than what we had.
Yeah. But have you guys tried the pivot mechanism at all?
No.
Like very fine pivots?
No.
Yeah. Is it here somewhere? Have you guys set it up? I think if you guys want me to help you, the teams that set up your projects here as soon as possible, because then I can just hang out here as much as possible. And for Cam, you can ask if we can borrow for a day or two even. Steve Monosmith's lab is also fine. But just, I'm saying, like, bring your projects here, because it'll take 15 minutes to debug, come up with 30 different ideas, and then you know that you're trying them back to back to back to back. Because, if everybody is kind of dispersed and you guys are not spending time together, you really can't make progress. So my biggest advice would be is bring a setup, bring 10 different plants here, and so that we can prototype 10 different mechanisms on it and see whether any of them. Have you guys tried the glitter idea, by the way, as yet? Okay. Yeah, so just ping me. It would be very valuable to push the bounds on the materials. I think that is a project that with simple sets of materials, you can very quickly set things up. But it does require precision in your approach. Like you're measuring something that is astronomically small and you're trying to make it macroscopic. So it's going to require a lot of ingenuity. And so the only way to do that is to actually physically prototype a ton of them. You might want to also choose plants of different stiffness. Some plants are too soft, so they cannot handle your mechanism as you attach to them, while other plants might be a little bit stiffer. And it's not so obvious to me what might be an ideal plan to detect it. I mean, clearly the fastest growing plants are the easiest to detect. But it's useful to have a few. Do you guys have bamboo shoots? So just go to the plant store. You guys, how much money do we have, by the way, from the department? $3K or something?
Yeah, something among those lines.
Okay, so then, guys, everybody has a budget, $100, $200. Go spend it. Get some stuff. Get things here so we can actually see. Bamboo shoots are super easy to get. Go see what other methods might be there to actually measure the rate. Do you have quantitative growth rate numbers? So you know what the amplification number should actually look like. And I think one thing to brainstorm on is the lightest mirrors. I mean, I'm thinking mica, so you guys should get some mica. What could be the mylar is another one. Anodized mylar is also an incredible mirror. It's very common. We might even have in the shop, right? Have you seen mylar in our lab? I think Charlotte might know because we used to use mylar for some of the origami. So, but anodized mylar is a polymer that has still a mirror-like property. So ultralight mirrors, because if your mirrors are too heavy, then probably cannot make the kind of display. Okay, next we'll take something online. Vaibhav and team. Shiva, go ahead.
Yeah, hello Manu. So
we have been trying to come up with the optimal flow rate. So the last time we decided was
Yeah,
like
what
one.
about your project? Nobody knows here. What are you doing?
Oh yeah. So there's a disease called schistosomiasis. I think you covered that in one of the classes, right?
Yes.
So we are trying to make a machine learning based diagnostic tool for detecting the schistosomiasis hebetobium egg in urine samples specifically for now, and will then mount the urine sample on the planktoscope and click images of the sample while it's getting pumped, and so on those images we'll run a machine learning model which will be able to detect whether the eggs were present in the sample or not, to conclude whether the patient has the disease or not. So yeah, currently we were thinking of how to like make come to an optimal flow rate so as we are covering as much volume as possible and not missing out any of the eggs in like the motion blur.
Yeah. So Weber, one thing that you might not know, since we last spoke, we have a very simple script now that literally records the video, the entire video of continuous pumping, rather than using a stop flow
Yeah,
protocol.
yeah. Uh-huh.
It uses a continuous flow and it just
Yeah.
records. I don't know, last time, did you guys use that? No.
No.
Yeah, so talk
So
to Ethan in the lab. Ethan has
all
a
right.
script now. It's a very simple script, and you would
Uh-huh.
then, it's a guarantee that you don't miss anything. And this is important for diagnostics because even if a one egg is missed in 10 ml, that was the whole point, and you missed it. So use a second script. It's just another script that runs on planktoscope.
Understood. So the motion blur isn't a problem with the script anymore.
Say that again.
So with this new script, will the motion blur not be a problem anymore?
No, I think motion blur is a, one of the things that we had earlier thought about is motion blur comes in if we are pumping something too fast. And so there is a trade-off. It's still slow enough that you don't really have motion blur. But what you do have to do is from the video, how do you segment the video to not double count? Then it's kind of the opposite problem. Algorithmically, video is still just a whole bunch of images. And these objects are actually rotating when they're flowing. So they look
Yeah.
different. And so, you have to think about once detected, you have to remove X number of frames. But it's one approach. At the end of the day, the current parameters are there in the current planktoscope with the stop flow that you get 100% volume. You
Yeah.
can keep using and playing with it. But practically, things can fall on the edge. And so you can actually miss parasite because if you're trying to do a sensitivity that's 100%.
Understood.
So
And
play
yeah,
a little. And when is the Nigeria trip?
22nd July.
Okay, so you have time. Yeah.
Yeah.
But have you started collecting data with your unit?
So we don't have. I've ran it using the local pond water sample and everything, but we don't have access to the parasitic eggs right now.
I see. Talk to William if it's possible to ship them to India. Fixed
Understood.
eggs. Yeah, you know
Yeah.
William, right? Yeah.
Yeah.
Yeah, I think fixed eggs should be totally fine.
Okay.
Otherwise, we would be stuck in. Do you have enough data from last time? And the ML model has worked well or
Yeah.
no?
Uh, it has from the last time. Like there were clear differences in the confidence level of impurities and the actual eggs, but I would still say the data set wasn't big enough last time.
I see. Okay, let's take it offline. I'll talk to William. Let's figure out a way to get eggs to you.
Understood.
But one of the things that you should do is for Wednesday next week, what do
Yeah.
you want to use as a target? is there a sub-problem that you want to tackle as a team that you have all the supplies for? What would that be? I mean, this volume issue would be phenomenal to figure out because this is about bigger. So in a planktoscope traditional application, a few plankton get lost, no big deal. It's an ecological application. If we now take that machine and turn it into a diagnostic application, even a single egg that's missed is a problem. So I like that you're focusing on that, and let's come up with a clever way to account for that. I wonder whether population beads could work. What if we add something in the urine at a known density and you use something like that as a way to test that you were able to measure the known object in the concentration that you had put in. And if that was off, something is not right, and then that test is unvalidated. Do you see what I mean?
Yeah, understood.
So you
mixing
are
in a
simultaneously while you're doing the diagnosis, add cheap beads to the water at a known concentration, run the system and check whether you were able to make the finite counts to confirm that what you added turned out to be true. So it's a little bit of a control built in the same test. That would be a fun idea to test. And then this would also give you a sense whether you are doing this. What is your LOD, limit of detection, or how small a thing that you need to spike in your water that you could still test it?
Understood.
Yeah, I was just thinking, Professor. Yeah, sorry.
Yeah, go ahead.
I was just thinking when we were discussing that. What about the shutter speed kind of thing? Now we are making video. That should not be a problem.
Rolling shutter is a really clever idea too. If that could be synchronized. In the old days, we had built a system where we built a synchronization with a laser that the camera only takes a picture when a laser passes by the tube and the egg coming by. So we did something like that, and a trigger system like that could be built. You guys could also choose that as a criteria. There are some very clever ways of hacking together a laser trigger. Laser pointers are super cheap, and then you only take picture when something is there. It's just that I'm a little bit worried about the tunability because, you know, urine will have debris of cells. It will have some things it will trigger on, some things it won't trigger on. So it's a little bit complex, but it's something that's been on our queue for a longest while. Read about laser trigger-based flow-through microscopy. It's a good idea. Yeah. I think between the two of these things, yeah. All right, I'm gonna keep going around. Yeah.
Okay, so one last thing from the light went anyway. So I was just saying.
Yeah, there's a power.
I mean, it's a moving sensor thing anyway. So I was saying, Professor, about the last point when we were moving the what is that called drone. So I'm saying like we have a bigger drone, and in the middle, right? We kind of put like exhausters like a pump, suction pump. Would that not help? Like maybe it's a thought experiment. I'm just thinking. I don't know how would that work. But like large wings. But
what I was thinking was utilizing the power of the motors from the drones itself. Why add another suction system when you have this immensely powerful fans? You should just be able to figure out how to redirect without not disbalancing the drone and still be able to get suction. But you know, I think I'm a little worried that if you don't think about the physics of a drone, you will never catch a mosquito because its whole job is to push air away by definition. So you have a paradoxical situation, but that's also where it's a very good grounds for creativity. And maybe flying very low and sucking in from the top is also not too bad. So yeah, I mean, think about it. That's the whole point. But there is somewhere in that space, there is a solution. Okay, let's keep going. I see two people that left. Those were the only ones that hadn't talked about their projects, unless they are in your teams. No? Are they in anybody's team? All right.
No, it was in tech.
No,
Or
is he in
Oh,
plan?
no, is yes.
Okay. Okay,
Yes.
no is, but one person
and then
left,
Jasmine.
Jasmine. In anybody's team? Okay, we'll ping. Anybody else online? Any projects? Kamal, go ahead. I haven't heard about what you want to do. It's 1 week left.
I'm working with Indumita and Kshitij on
Yes.
the river blindness non-invasive imaging project. And
Awesome.
so, yeah, so we pulled a couple of papers out and a couple of algorithms. We wanted to talk to you last time, but Friday the class got pumped, and
we can talk now, actually, right after the
the
class
problem
ends.
is that
Anybody else in the team is here.
yeah, so the two people who are aware of the simulation aspect, both of them are not here. So I'm just filling in for them. But
time, I am back now. So if today doesn't work, we can also do tomorrow.
I think Indu has an exam tomorrow, but I will check with her and maybe we can fix a time tomorrow. It'll be nice because we pulled out one pi membrane package and one COMSOL study from 2024 that has used basically a model to figure out the stiffness of the skin in a with particular parameters. And so we were trying to think if we could build on
using
that.
an electromagnetic capacitive measurement.
Yeah, so the thing is, there are two methods that we had thought of to go ahead with. One was the indentation based method. That we think is the more sensitive one. And based on the current literature that I found, I feel like we could bet more on that than the impedance one. The impedance one is way too sensitive to noises. And there was also one 2024 study that showed that what are the thresholds that they could measure, and what is the thickness that they could go to. Looks like from the known data on the CDC and NIH website, we could only find thicknesses that were on like maybe half the thickness of the thing that forms. So the indentation based thing looks like
how you were thinking. The idea would be is on Wednesday, try to compare these two methods. I really like this. Yeah, because it's a very quantitative method used in material science forever. There is a remarkable amount of studies, but I don't think I have explicitly seen indentation on skin being used in diagnostics.
So there's one study that came up which made a DIY tool which was less than $100. It's an indentation based sensor, and they measured it for old people, young people, different parts of the arm, and so they could find some differences.
What were they trying to measure?
They were trying to measure the shear constant, the Young's modulus, essentially.
You guys know this test of the skin tone test? You know the skin tone test?
No.
Yeah, it's a classic. It's a $0 test. You just pull on your skin and you let go.
You might need some water.
I need some water. And at the rate at which your skin comes back gives you a good sense for how much water you need. I need some water. Very good. And it's the opposite. What you're doing is indentation. Take your skin, pull it a little bit and let go. And from dynamic, we should make this test more quantitative. That would actually be fun. Like
No, that'll be cool. Yeah, that looks like there is a lot of way to like extract data frugally based on this.
I like the indentation. Let's play with that. But I would still like you guys to compare it to the impedance.
All right. We could start with the COMSOL package and the
stiffness can arise from many different mechanisms.
Right.
And so it's useful to have other mixes in the background too.
All right. So I'll fix a meeting with you offline. Me, Indu, and you can meet outside of the class.
Help finding a time.
Yes, sure. I'll write to you.
It's like that's the hardest possible thing in the world. But we will make that happen now. Yes.
All right. Thank you so much.
Yes, sometimes. Late evenings, if you are all in India, I can do a 10 p.m. onwards meeting.
I think that's the best for us because Kshitij and me always look for late evening time. So
no, not your my late evening. That'll be more.
Okay. All right. So then mornings.
Like 10 p.m.
Right. All right. I'll speak to Kshitij and get back to you.
Yeah. Anybody else on projects? All right. I was gonna cover something, but what time is it?
11:40.
I could maybe let me just say one word, less than 2 minutes, and then I'll just stay to talk to any team that wants to talk and brainstorm. I think. So first of all, what are the bounds of the presentation? We talked a little bit about it.
Bounds as in
Like amount of time, maybe 10 minutes is a good.
We have about 7 teams, I believe, total.
Yeah.
So
yeah, I mean, we should, at the least 10 minutes is a good. Let me say it this way. I don't really care about, this is not a pitch. It's not for raising money. It's not, I want you to really own and understand your problem. You should be able to, and that you've done already in the past. So that part is there. So now this time it really is about solutions. Show everyone every possible thing that you've tried. I think it's about hustle. So the last presentation should be about hustle. It's like, look, we tried 10,000 things and none of them worked. That's the most successful project. If you tried one thing and it didn't work, we should try more, right? So what I want to see is not some polished talk. What I want to see is hustle. That you actually took the principles of what we were learning and you tried many things. That's the goal of this class. It's not some polished talk. I know you guys all are super good at making polished talk. I'm saying every inch of your time dedicated to actually doing things that move the project forward. And because you have many of them, and then this will give you a sense of, for some of you, the question really is that, the class is just, it's a fun thing to do. The question is, do you actually care deeply about this idea that you would take it forward? And now would be the time to rule out many, many, many ideas to say, look, we have an inkling. We saw light at the end of the tunnel. This is going to work. Then you approach it in a very systematic way, and then we can build resources around it. We can grow those sets of projects. So that's kind of item number one. Having some amount of small success really inspires and motivates you to think about that, oh, I can actually dedicate a significant portion of my time to this. But that doesn't come without hustle. It doesn't come from so that's kind of my honest feedback on presentations. Any questions? The more demos you bring to the table, the better it looks. So just bring a ton of stuff. It's important to play around and kind of say, oh, and I was thinking about this and this might work and that might work. They can be as rough as prototypes. They can be as polished as you think. But progress is made by some of these things. We can close the room and think about 1,000 ideas, but it's also about trying a few of them. Any questions for Wednesday? Then I'll just say a word about Sisal. So now everybody has 24/7 access to this room or no? Still are we stuck with access?
I didn't get an email about it. I applied for access.
Youngjin, do you know where Kevin went? I had mentioned that nobody got any access cards. Do you guys know what time does this space close? Have you guys tried off time hours?
It's hard to get in. You can't, after 5:30, you can't get into this building, let alone.
They got to like linger here till 5:30 and then it's.
You mean in the building is the issue, the building access or the room access?
Freedom closes at 5:30. Well, don't have badge access.
But if you have this room access, then by definition you have it.
Last quarter for Capstone, we had access to this room.
But not the building.
Not the building.
I see.
We had to just hope some nice TA or lifeguard was around.
Yeah, I think one of the threads to do would be is either people in my lab, we can let people in, but why would they be? If they give you access to the room, they should give you access to the building.
So if you linger around the idea.
Okay, let me ask Kevin what the access issue is. Has anybody tried?
I don't think we have access to the room either, because I came by yesterday, probably around 5:30.
When you can.
Got into the building.
Kevin, do you know what the update is on access to this room?
There's a QR code outside, and I think you fill it out, then.
But somebody filled it out and
Okay.
never.
Is Youngju here? I think.
That would be urgent.
Yeah.
Because if I'm saying people should give access. And it's useful to look up here.
Okay.
But I think the idea would be is to, if you Slack me and I'm in the building, I'm happy to just come by, like quite literally. Now this week is all hands on deck. And maybe on today's what?
Wednesday.
Today's already Wednesday. Yeah, I think basically from now onwards, Slack me and I'll try showing up. You guys are spending time here. That would be the easiest way. And I can also do some office hours, like every day at 4 o'clock, I could just come by and it's working. Does that work for people? Is 4 o'clock a good? Yeah, I think most of the day. Yeah, let's find access time.
Yeah, I'm messaging Mong right now.
You know what, actually, yeah, maybe I'll cover, let's just do projects today. I'll cover a little bit of Cycle on the Monday class, just to kind of give sense on the material science side of the story. Let me just sit down and talk to anybody else who wants to spend. Let's spend a little bit of time. I think two of you are still there, right? Let's sketch out what is the first steps of things you guys should be on. And then anybody else. On the drone side, take a look at papers on people who have already mapped the flow field around drones and see whether there is a modification associated with it. I think, yeah, my intuition is that if you fly low, could imagine something.
Yeah.
Yeah, from the top.
Yeah.
But concern, if the drones perturb airflow so quickly, most of the swarms would sense that flow from far away. So that's the problem with the moving target, because you don't have a bait, and even if you have a bait, unless we could do a dangling thing where the drone is far away.
Okay.
So you should figure out what is the length scale at which the drone's air perturbation, how do they decay? Like, would it be 10, if it's 100 meters, then it's too crazy. But if it's 10 meters, then it's doable. And you're thinking about a drone and the craft is far enough from the main body of it.
We're gonna go meet right now.
Yeah. Yeah, let's do a quick chat on the plant side of it. Then have some paper. Niaz, yeah, right to Niaz. And Niaz, yeah, looking for some
Yeah. I'll just keep the Zoom call.
Hello, Kevin. Is the class done?
I think we're just having individual project meetings, but I'll stay on in case you want to ask any questions.
All right, understood.
Yeah.
We'll just take it from here. You guys can just also.
As for reading the project ideas on Discord, like I think if you want a particular feedback or input, then like you can ask, but otherwise, I think all our focus is being put on the existing projects right now. But feel free to keep the discussion going with any ideas you're curious about.
I mean, overall, what was the intuition? Did we want to get the samples also?
Okay, Kevin, thank you.
Clinical sample we're getting? Okay, I'll try for that.
Okay.
Let's see. I mean, I think
To the